In this video, I'll teach you how to convert the units of force and weight. Force is typically measured in newtons for the SI system, but depending on the problem, you might also see force in the units of pounds force, dynes, and kilogram meters per second squared. Weight is just a specific type of force. It's the force of gravity acting upon mass. You'll often need to convert between mass and weight using gravity in meters per second squared, but it could also be represented in feet per second squared. Typically converting force and weight units, you'll be using the equations force equals mass times acceleration and weight is equal to mass times gravity. Now let's do some examples. Convert 1,500 newtons to kilonewtons. First, we need to understand the prefix of kilo. The prefix kilo means 1,000. So 1 kilonewton is equivalent to 1,000 newtons. So to convert from 1,500 newtons to kilonewtons, we need to multiply through our conversion factor of 1 kilonewton per 1,000 newtons. Multiplying through this, we see that the newtons cancel and leave us with kilonewtons. Solving this, we get that 1,500 newtons is equivalent to 1.5 kilonewton. Convert 10 pound force to newtons. In order to convert from pound force to newtons, we need to know that 1 pound force is equivalent to 4.448 newtons. So to convert 10 pound force into newtons, we need to multiply through our conversion factor of 4.448 newtons for 1 pound force. Multiplying through this, the pound force cancel and leave us with newtons. Solving this, we get that 10 pound force is equivalent to 44.48 newtons. A person has a mass of 70 kilograms. What is their weight in newtons on Earth? First, let's identify our variables of mass is equivalent to 70 kilograms, and gravity on Earth is equivalent to 9.8 meters per second squared. In order to know their weight, we need to know the equation W equals mg, or weight is equal to mass times gravity. So calculating their weight, we plug in our variables of 70 kilograms times 9.8 meters per second squared. This equals their weight of 686 kilograms times meters per second squared. To find their weight in newtons, we need to know the conversion that 1 kilogram times meter per second squared is equivalent to 1 newton. So their weight on Earth in newtons is equivalent to 686 newtons. An object weighs 490.5 newtons on Earth. What is its mass in kilograms? First, we'll identify our variables. The given weight is equal to 490.5 newtons. And on Earth, gravity is equivalent to 9.8 meters per second squared. In order to find their mass, we need to use the equation of weight is equal to mass times gravity. We can rearrange this equation to solve for mass. This gives us that mass is equivalent to the weight divided by gravity. Plugging in our variables, we get that mass is equivalent to 490.5 newtons divided by 9.8 meters per second squared. 1 newton is equivalent to 1 kilogram times meter per second squared. So solving for mass, the seconds squared and the meters cancel and leave us with just the kilograms. So our mass is equivalent to 50.1 kilograms. An object weighs 220 pound force. What is its mass in kilograms? First, we'll identify our variables of weight is equivalent to 220 pound force, and gravity is equivalent to 9.8 meters per second squared. In order to find our mass, we need to use the equation of weight is equal to mass times gravity. We can rearrange this equation by dividing by gravity, giving us that mass is equal to weight divided by gravity. In order to use this equation, though, we need to first convert our 220 pound force into newtons. We will use the conversion factor of 1 pound force is equivalent to 4.448 newtons. So to convert, we'll multiply through our conversion factor of 4.448 newtons over 1 pound force. Multiplying through this, the pound force cancel and leave us with newtons. This gives us that 220 pound force is equivalent to 978.608 newtons. Now we can plug into our equation for mass by dividing our 978.608 newtons by our gravity of 9.8 meters per second squared. This gives us a mass of 99.9 kilograms. A bag of sugar has a mass of 2.27 kilograms. What is its weight in pounds force on Earth? First, we'll identify our variable of mass is equal to 2.27 kilograms. And we want to find the weight of this in pounds force on Earth. In order to find the weight, we'll need to use the equation that weight is equal to mass times gravity. And gravity on Earth is equivalent to 9.8 meters per second squared. So plugging in, we get that weight is equal to 2.27 kilograms times 9.8 meters per second squared. This gives us the weight of 22.246 kilograms per meter squared. And kilograms times meters per squared is equivalent to newtons. Now we can use our conversion factor of 1 pound force is equivalent to 4.448 newtons. To convert our 22.246 newtons to pound force, we need to multiply through our conversion factor of 1 pound force over 4.448 newtons. Solving this, we get that 22.246 newtons is equivalent to roughly 5.00 pound force. A very delicate force sensor measures a force of 50,000 millinewtons. Convert this force to kilonewtons. First, we'll identify our prefixes. Milli, notated by the little m before the newtons, is equivalent to 10 to the minus 3, or 1 over 1,000. This gives us that 1 newton is equivalent to 1,000 millinewtons. Kilo, notated by the lowercase k in front of newtons, is equivalent to 10 to the third, or 1,000. So 1 kilonewton is equivalent to 1,000 newtons. Now knowing our conversion factors, we can convert 50,000 millinewtons to kilonewtons. First, we'll convert from millinewtons to newtons by multiplying through our conversion factor of 1 newton is equivalent to 1,000 millinewtons. Then we'll change from newtons to kilonewtons by multiplying through our conversion factor of 1 kilonewton is equivalent to 1,000 newtons. Multiplying through this, we see that the millinewtons cancel and give us newtons, then the newtons cancel to give us kilonewtons. This works out that 50,000 millinewtons is equivalent to 0.05 kilonewtons. A force of 2.0 times 10 to the 5 dynes is exerted on an object. Convert this force to newtons. The conversion factor between dynes and newtons is that 1 newton is equivalent to 10 to the 5 dynes. So to convert our 2.0 times 10 to the 5 dynes into newtons, we need to multiply through our conversion factor of 1 newton over 10 to the 5 dynes. Multiplying through this, the dynes cancel and leave us with newtons. And because we are equivalently dividing 10 to the 5 by 10 to the 5, this is the same as saying 10 to the 5 minus 5, which is just equal to 10 to the 0, which equals 1. So solving this, 2 times 10 to the 5 dynes is equivalent to 2.0 newtons. An astronaut has a mass of 80 kilograms. What would their weight be on the moon in newtons? The acceleration due to gravity on the moon is equivalent to 1.62 meters per second squared. First, we'll identify our variables. We were given the mass of 80 kilograms and a gravitational constant of 1.62 meters per second squared. In order to find our weight, we'll need to use the equation of weight is equal to mass times gravity. Plugging in our variables, we get that the weight on the moon is equivalent to 80 kilograms times 1.62 meters per second squared. Solving this, we get that their weight is equivalent to 129.6 kilograms times meters per second squared. And kilograms times meters per second squared is equivalent to newtons. So their weight on the moon in newtons is 129.6 newtons. A 15 kilogram object is accelerated at 3.0 meters per second squared. What is the net force acting on the object in pounds force? First, we'll identify our variables. We were given that mass is equal to 15 kilograms, and an acceleration is equal to 3.0 meters per second squared. In order to find the net force, we'll need to use the equation of force is equal to mass times acceleration. First, we will find the force in newtons by plugging in our variables of 15 kilograms times 3.0 meters per second squared. This gives us a net force of 45 newtons. We need to know the conversion factor of 4.448 newtons is equivalent to 1 pounds force. Now, to convert our force from newtons to pounds force, we need to multiply through our conversion factor of 1 pounds force is equivalent to 4.448 newtons. Multiplying through this, we see that the newtons cancel and leave us with pounds force. This gives us that the net force acting on the object is equivalent to 10 pounds force. If you found this video helpful, don't forget to leave a like, subscribe, and let me know in the comments what topics you'd like to see next. Thanks for watching.